Hello friends, welcome to EPG Pathsala. I am Dr. Ujjwal Kumar from School of Environment and Natural Resources, Doon University, Dehradun. Today I am going to elaborate upon urban climatology, which comes under the paper Climatology. First of all, let us discuss what could be the learning outcome of this module. While going through this module, you will be able to define urban climatology, distinguish between urban and rural climatology, define and explain urban heat island, discuss the concept and effect of heat island, establish the relationship between air pollution and urban climate, explain the climate extremes in the cities and suggest mitigation and control measures to contain urban heat island and urban air pollution. So, all of us are living either in rural or in urban areas. You might be living in an urban area, but most likely you might have visited the rural areas as well. In the same way, you might be living in rural area, but most likely you might have visited some urban areas as well. I hope you must be aware about the rural as well as urban scenario. You may notice the difference between the two with respect to living space, ventilation, dwelling houses, roads, traffic, accidents, markets, industries, crowd, purity of air and water, etc. Both of these spaces are distinctly different. You may know very well that the urban places have more percentage of construction of black-topped surface cover than the rural space. Huge and many times unmanageable traffic creates unimaginable noise and air pollution. Waste disposal is a big challenge there, leading to both air and water pollution. Many of these are a day-to-day affair in the urban areas and have a great difference with that of the rural areas. With this perspective in mind, in this module, an attempt has been made to study the urban climatology, which is distinct from its surrounding rural areas. So let us first discuss about the concept of urban climatology. The term urban climatology came into vogue because of the ability of cities to modify the local atmospheric condition owing to its distinct characteristics such as presence of large number of concrete buildings, emissions from traffic, waste heat, materials, etc. All these, apart from others as well, give cities distinct climatic conditions than that of its surrounding rural areas. Hence, urban climatology is basically a relative term which compares cities' climatic conditions with that of its surrounding rural areas. So, to put into perspective, urban climatology is concerned with the study of climate effect of urban areas and the application of knowledge acquired to the better planning and design of cities. It is defined primarily by its focus on the city and incorporates aspects of many different disciplines including meteorology, climatology, air pollution science, architecture, building engineering, urban design, biometeorology, amongst others. Each of these disciplines has its own focus and has developed distinctive tools and methods appropriate to their interest. As a result, much of the knowledge base that urban climatology draws upon is fragmented and is still in the process of being assimilated into a comprehensive and coherent field of study. The present day demographic data of population for the planet Earth has reached more than 7.5 billion, of which 54% lives in urban areas, a proportion that is expected to increase to 66% by 2050. The 2014 revision of the World Urbanization Prospects by UNDES's Population Division notes that the largest urban growth will take place in India, China and Nigeria. Thus, the continued urbanization of the populated areas will lead to inhabitation of more large cities and megacities. The substantial increase in the population is reflected through changes in the living patterns as well as the alteration of the natural topography and land cover. So, let us now discuss urbanization and microclimate change. The first assessment report on climate change and cities, ARC3, notes that cities being home to over half of the world's people and are at the forefront of the climate change issue. Climate change exerts added stress on urban areas through increased number of heat waves, threatening the health of the elderly, the infirm, and very young. More frequent and intense droughts and inland floods compromising water supplies, and for coastal cities, enhanced sea level rise and storm surges affecting inhabitants and essentially infrastructure, property, and ecosystems. At the same time, cities are responsible for about 70% of the greenhouse gas emissions, while they cover only 2% of the global land area. With the passage of time, it is likely to increase further. These challenges highlight the need for cities to rethink how assets are deployed and people protected, how infrastructure investments are prioritized, and how climate will affect long-term growth and development plans. So there are different approaches to urban climatology. So we will now discuss approaches to urban climatology. A number of studies suggest that cities modify the overlying atmosphere significantly in nearly every respect. These modifications are the result of changes in the surface cover, fabric, and geometry, that is the urban form, and the anthropogenic emission of waste heat, water vapor, and materials, that is the urban function. Hence, cities face special climatic conditions and can broadly be covered under the three categories. First, urban heat island. Second, air pollution and urban climate. Third, the climate extremes. So now let us explore each of these one by one. First, let us discuss urban heat island. Cities already tend to be hotter than surrounding urban and rural areas due to absorption of heat by concrete and other building materials and the removal of vegetation and loss of permeable surfaces, both of which provide evaporative cooling. This is further triggered by the greenhouse gases in the atmosphere, which also absorb heat and re-radiate it towards the earth. This overall effect of cities getting significantly warmer than the surrounding areas is known as urban heat island effect. In other words, an urban heat island is an urban area or metropolitan area that is significantly warmer than its surrounding rural areas due to human activities. The temperature difference usually is larger at night than during the day and is most apparent when winds are weak. Urban heat island is most noticeable during the summer and winter. So now let us discuss what is the characteristic of urban volume layers that gives its the phenomena of urban heat island and distinct urban air pollution. So urban climatic condition leading to urban heat island and other effects can better be understood if the urban volume layers that hold the climate interactions are taken into account. There are three main urban volume layers that holds the climate interactions. The urban canopy surface layer that has the street level microclimate circumstances. Second is the urban boundary layer that has the inertial surface roughness sublayer as an envelope for the urban roofs. Then urban dome layer that has the regional mesoscale climate conditions. The heat transfer between these layers are due to the following: radiant heat exchange in between human and canyon surfaces and in between canyon surfaces itself. Convective heat exchanges between canyon surfaces due to reflection and emissions. Heat generation within homogeneous pattern. That heat, if trapped, it is called heat islands. Up-down air flows within the three levels of urban spatial layers. Now, how can we monitor the urban heat island? So, we have to measure certain parameters. So, to study the effect of urban heat island requires continuous monitoring of following meteorological parameters in and around the city, that is temperature, wind velocity, relative humidity, cloud cover, solar insolation, and radio sound data. Radio sound data are something that provides for the vertical profile of the meteorological parameters. Now, second way to look at the urban heat island is through modeling. Since monitoring provides for the observational data only at the selected locations, To study the overall effect of urban heat island on the city, it is necessary to interpolate these data throughout the city using the physical laws that can define the processes, interaction of different urban climate layers. This task is accomplished through computer simulation and modeling. The urban climate models focus on the interaction between surface layer comprising of roughness and inertial sublayers and mixed layer above where the urban surface exchanges are blended into the wider atmosphere and transported downwind. This urban climate model is further coupled with the mass scale meteorological model in order to understand the impact of climate change on the cities and vice versa. So, what are the effects of urban heat island? In fact, the urban heat island effect is suspected of warming urban areas up to 3.5 to 4.5 degrees centigrade more than the surrounding rural areas, and this differential is expected to increase by approximately 1 degree centigrade per decade. The temperature differences between urban and surrounding rural areas can reach up to 10 degrees centigrade for large urban agglomeration. The built environment, including buildings and roadways that absorb sunlight and re-radiate heat, combined with less vegetative cover to provide shade and cooling moisture, all contribute to cities being warmer and susceptible to dangerous heat events. Urban heat islands are directly related with the health of the people. In fact, in urban, for example, in the 2003 European heat wave that is estimated to have caused about 70,000 victims, a higher percentage of the causalities in France came from urban areas. Increasing temperature can affect mortality in a number of ways, including heat-induced mortality, famine, exacerbation of non-infectious health problems, and spread of infectious disease. Now, let us look at urban heat island, local climate, air pollution, and health. Urban heat island effects can generate changes in local atmospheric cycles, changes in solar flux and chemical composition of near ground air masses can cause formation of photochemical smog and reduce air circulation, which would otherwise diffuse in the concentration of air pollutants. Warmer temperature due to climate change and urban heat island effects, all other things held constant, may increase concentration of conventional air pollutants such as ozone and acid aerosols, as well as the emission of particulates and allergens. Moreover, higher temperature due to climate change may actually make it more difficult to control the formation of some pollutants such as ozone, which can exacerbate chronic respiratory diseases and cause short-term reflections in lung functions. Urban heat island is also directly related to energy demand. By aggravating heat-related climate change impacts, urban heat island effects are likely to increase future energy demand. In the United States, for example, an estimated 3% to 8% of annual electricity use is required to offset urban heat island effects. Adaptation to rising temperature by increasing air conditioning can also further increase urban heat island effects. For instance, massive air conditioning has been shown to increase urban heat island effects up to 1 degree centigrade. In India, there are several studies that suggest that urban heat island effect on cities like Delhi, Lucknow, Jaipur, Guwahati, among others, is clearly visible. The increase of air conditioning usage in cities like Delhi has grown manifold. This must be triggering the urban heat island effect even further. Now, let us discuss about air pollution and urban climate. Air pollution in cities is an ever-rising concern for both the developed as well as developing world. Historically, Los Angeles smog and London smog are two most infamous incidents of cities choking under the pressure of air pollution. In recent times, Paris smog in March 2014 and Delhi smog in 2016 have continuously been in news because of dense smog laden with loads of air pollutants covering the entire city. Indoor air pollution and poor urban air quality are listed as two of the world's worst toxic pollution problems in the 2009 Black-Smith Institute's World Worst Polluted Places report. According to 2014 World Health Organization report, air pollution in 2012 caused the deaths of around 7 million people worldwide, an estimate roughly matched by the International Energy Agency. So now look at what are the causing agents. So there are several air pollutants. It can be gases such as carbon monoxide, nitrogen dioxide, ozone, sulfur dioxide, and VOC, that is volatile organic compounds, among others, and the particulates, the aerosols. These air pollutants are released in the atmosphere mainly through anthropogenic sources such as industry, traffic, power plants, release from waste, marshy lands, etc. Some of these gases have greenhouse properties, thereby altering the temperature of atmosphere. Black carbon among particulates also causes warming effect. In general, the gases and particulate components emitted into the atmosphere lead to a change in the composition and transparency of air over large parts of the world, mainly over the large cities, and in this way, nearly every element of climate in these areas is modified. So, we now look at what are the components of significant change in urban climate due to air pollution. In fact, investigation by different researchers show clearly the significance of change in the following components of the climate of cities. First, intensity of solar radiation, atmospheric visibility, temperature distribution, relative humidity, local wind distribution, and precipitation distribution. Intensity of solar radiation. The modification of intensity of solar radiation is mainly because of increase of turbidity of incoming radiation by atmospheric pollution. A reduction in the duration of bright sunshine in large cities is also found. In fact, one study that compares the duration of sunshine at several stations in and around the center of London, the average duration of bright sunshine decreased considerably towards central London. The loss of sunshine in central London was greatest during the winter month. When atmospheric pollution was heavy due to the higher level of domestic heating, it is evident that the change of the radiation budget in large cities affects the temperature distribution compared with that of the countryside and is the cause of some of the specific characteristics of urban climate. It is also evident that the effects of a typical urban climate are more marked under calm, sunny weather conditions. With respect to the reduction of incoming solar radiation due to the haze dome above cities, it is generally agreed that the decrease of direct solar radiation amounts to 10% to 20% decrease of scattered sky radiation. Visibility. There is no question that the visibility in cities is greatly reduced under certain conditions. Accumulation of condensation nuclei produced from many anthropogenic and industrial sources in and around cities leads to a decrease of visibility and often to the formation of fog. It should be noted that the frequency of fog in urban environment is higher in spite of the fact that the air temperature is higher and the relative humidity lower in cities compared with the countryside. The explanation for this contradiction lies in the mechanism of fog formation. With high concentration of sulfur dioxide, the formation of sulfuric acid by catalytic oxidation on the surface of particulate matter in a humid environment leads to the formation of a small droplets of fog under condition in which fog would not form in a pure atmosphere. This has many unpleasant and dangerous consequences with respect to the harmfulness of urban fog. Now let us look how temperature distribution gets affected. So, as discussed under urban heat island section, temperature over urban areas is higher than that of its rural surrounding because of urban forms and structure. The increase of air pollutants, particularly greenhouse gases and black carbon aerosols, aggravates the problem and enhance the urban temperature further. Now let us look at how local wind distribution gets affected. The heat island effect is also the main factor leading to the formation of an urban wind system. But as is the case with the temperature difference between cities and surrounding countryside, the development of urban wind system is associated with low wind speed and with stable temperature lapse rate, that is predominantly with anticyclonic weather situation. The wind direction was changed within the city and the wind speed was considerably reduced within the built up areas due to the increased roughness. Undoubtedly, the urban circulation system is very important in connection with the dispersion and distribution of pollutants produced from sources in the city area. When we reduce our observation to the micrometeorological scale, very interesting information can be gained on the distribution of pollutants in streets and on their dispersion in relation to the wind velocity and wind direction. Now let us look at how this air pollution affects the precipitation distribution. The increasing air pollution, particularly the aerosols, also alter the precipitation over the city. Aerosols provide the site for cloud condensation nuclei, and as a result, heavy downpour for a short duration occur over an aerosol filled area instead of long duration drizzling rain, which is the general characteristic of the rain. This also alters the distribution of precipitation over special areas, as most of the clouds get exhausted in the heavy downpour over the aerosol filled areas, and thereby dividing the rain in the nearby areas lacking aerosol contents. The city, which produces so many pollutants, is itself an obstacle to the dispersion of these pollutants, and thus increases the dangers associated with the accumulation of obnoxious components. There seems to be a general agreement that the increased concentration of pollutants in city air constitutes a hazard as far as respiratory diseases are concerned, apart from altering the general urban climate. Now, let us look at how climate extremes are being faced by the cities. The IPCC 2014 report clearly indicates that warmer region of the world is getting warmer and colder regions are getting colder and colder. And areas lacking rain will suffer further scarcity of rain, while regions receiving high amount of rainfall will receive further heavier rainfall. In fact, the climate of metropolitan cities like Delhi is shifting towards climate extreme. The higher summer months are getting hotter and hotter. The hotter summer months are getting hotter and hotter. Precipitations are getting heavier but of short durations. Cold months are getting colder and colder. These all are signs of climate extremes, and factors discussed above might have significant role to play to modify the urban climate. In fact, in one of the recent study by Vasco and Sharma analyzed real-world effects of river flows and rainfall data from over 160 countries, and they noted that there is a radical shift in stream flow pattern with more intense rainfall in cities, overwhelming infrastructure and causing flooding. But there is also observed phenomena of drier soils and reduced water flow in rural areas. The reason turned out to be the other facet of rising temperature. More evaporation from moist soils is causing them to become drier before any new rain occurs. It's a double whammy. More people are moving to the cities where floods are becoming more frequent and intense. At the same time, rural areas may be becoming drier with reduced river flow, impacting on agricultural productivity and the food security. Now the question comes, how can we mitigate these impacts? What can be the possible control measures? Now, since urban climate is being adversely affected by urban heat island and air pollution, to mitigate or to minimize these adverse effects, a two-pronged strategy is needed. One that concerns with city planning, design of buildings, use of suitable materials so as to minimize the urban heat island effect, and second, taking strong control measures to check the rising air pollution in the city. Urban climatologists work with architects, planners, and engineers to design new buildings and developments. They also work with regulatory bodies and local authorities, setting requirements in terms of what types of buildings or developments can occur. So let us look at urban forms, structure, and emissions. So a combination of various factors together contribute toward the peculiarities of urban climate, such as materials. The original or pre-existing landscape comprising of natural materials, that is soils, trees, grass, etc., have a striking contrast with respect to the material building up the cities like concrete, brick, asphalt. The difference in thermal and hydrological properties is attributed to the varying levels of absorption and storage of heat and water by the surface. The building materials used to reconstruct cities such as bricks, concrete, asphalt have high heat capacities and ability to conduct heat. These materials absorb and store large amount of heat in the day which is slowly released at night. Morphology of the city. The shape also changed in an urbanized landscape because of extensive development activities. The walls and roofs for house, factories, shops, high-rise buildings, parking spaces, etc. increase the surface area exposed at the surface, which results in greater absorption of incoming radiation from the sun and affects the flow of air across the surface. The vertical walls and roofs of buildings increase the area exposed at the surface, further enhancing the absorption and storage of heat. They also reduce the ability for surface cooling. Energy emitted from the surface is trapped in the urban canyons. The removal of vegetation and high impervious surface covers reduces water availability, limiting evapotranspiration. This means that available energy heats the building fabric and air and is not used up evaporating water. Now, next is emissions. A crucial component in the urban landscape is emissions through various sources. For example, heat from traffic, industry, the heating of building, or gases such as carbon dioxide, carbon monoxide from burning of fossil fuels, or particulates from industrial processes or traffic largely form the chunk of proportion which contribute towards absorption and transmission of energy affecting the urban atmosphere. Human activities release heat from various sources. This is an additional source of heat not available in rural areas such as air conditioning and other things. So, how to mitigate this urban warming? The following measures and strategies can be used and enforced to mitigate urban warming. First, changing the material properties of individual buildings and or the spatial arrangement of individual buildings and vegetation. Then, painting roofs and streets in light colors or using different types of road or roofing materials increase the amount of incoming solar radiation that is reflected and thus not absorbed by the surface, resulting in cooling. This approach has been extensively adopted in cities in hot environments. For example, around the Mediterranean for a long time. Changes in materials have the advantage that they can be used on current buildings, so do not require the cost or time of new development. Next is planting vegetation, provides shade and thus provides cooling at local level. It also increases evapotranspiration, reducing the amount of energy available in heat the ground or air in case of scarce availability of water. This process also results in cooling. The addition of water detention ponds and wetlands can be done. Innovative residential developments employing water-sensitive urban design such as rainwater harvesting system for the large buildings involving the use of grey water, reuse water to irrigate residential vegetation reduces the demand for water to be diverted into a city for irrigation purpose. Now, second pronged strategy is air pollution control strategy. We need to implement strong control measures to check the rising emissions leading to growing air pollution. Traffic, industrial and power plant emissions are the major culprits for the air pollution in city areas. Others include unmitigated construction activity, emissions from waste-infested marshy lands, etc. There are already emission norms in place for each of the industry sector, traffic and power plant. In designing an effective air quality control strategy, following considerations are important as per EPA recommendation. First is environmental. Factors such as ambient air quality conditions, relevant meteorological conditions, location of the emission source, legal requirement, noise levels and any ancillary pollution from the control system itself. Second is engineering factors such as pollutant characteristics, abrasiveness, reactivity and toxicity, gas stream characteristics, performance characteristics of the control system and adequate utilities. For example, water for wet scrubber, we can put air control devices. Third is the economic factors such as capital cost, operating cost, equipment maintenance, equipment lifetime and administrative and enforcement costs. So, these are the economic factors. Now, there is a concept of when we take all these factors into account, then there is a concept called sustainable cities come into the picture or cities contributing to global sustainability. In fact, nowadays there is a talk of sustainable cities treating the urban system as though it is an organism requiring sustenance. One approach that has been applied is to examine its metabolism, the input, storage and output that allow an urban areas to function. Inevitably, these exchanges across the urban-rural boundaries so that the impact of cities is felt beyond their limits. In this sense, cities are not and cannot be made sustainable. But it is possible, however, to assess the intensity of exchange and the geographical extent of cities' resource catchment. Urban sustainability then becomes a relative concept. The more sustainable city is the one which uses fewer resources to fulfill its function. Generally, relative sustainability is evaluated on a per capita basis, though there is a sense in which a city with a high natural population growth rate can be less sustainable as a result. Alternatively, a city that attracts more population from outside its boundaries will also increase its own resource use, but may actually decrease not resource use if the migrants would be using more resources if they had not migrated. Again, this serves to emphasize the importance of treating urban sustainability in a global context. In any case, there is an important sense in which the goal is not to have sustainable cities, but cities that contribute to global sustainability or to sustainable development. Now let us summarize and conclude our urban climatology module. The focus of this module has been to explain the distinctive features of urban climate, causes, interaction between urban areas and the atmosphere, the effects they have on one another, impacts on local climate, human health and others, and the possible mitigation measures to contain the adverse impact that so happens. Though the beginning of the observation of urban climatology is considered to be as old as to start with a Luke Howard book published in 1833 known as The Climate of London, the major progress in terms of urban climate modifying local weather, its interaction with the global climate impact and vulnerabilities has been achieved only in last few decades, especially the simulation and modeling studies. These studies put it beyond doubt that rising population, increasing built-up areas, reduction in green space, growth in traffic volume and emissions, industrial and power plant emissions, all of these have led to modify the city's weather considerably, that too adversely. And hence we observe the urban heat island effect, extreme weather in urban areas, choking urban air due to air pollutants, therefore rise in respiratory diseases, children's vulnerability to such diseases, adverse impact on plants, among other impacts. As stated earlier, there are many studies on Indian cities which clearly show that Indian cities are witnessing all of these adverse impacts. It is inevitable that these factors must be taken into account for any city planning. The city planning must include consideration of adequate green space, use of right kind of materials, encouraging public transport for daily commuting so as to reduce traffic load and emissions, proper control measures for the industrial and power plant emissions, making cities eco-friendly by using renewable energy sources such as solar, wind, and large apartments buildings should be made rainwater harvesting system enabled. Nowadays, the government has been focusing on these factors when they plan for city infrastructure, but it is largely up to the public to keep government on its toes to keep up the pace in real spirit and never give up, because it is the public which are the ultimate sufferers. Thank you very much.